Have you ever wondered how your computer communicates directly with other devices across the internet without a central server? That's the magic of peer-to-peer architecture, a revolutionary concept that's reshaping the digital world as we know it. Peer-to-peer architecture, or P2P as it's often abbreviated, is the backbone of many modern digital systems. It's an integral part of cryptocurrencies like Bitcoin, which use it to maintain a decentralized ledger of transactions. It's also the driving force behind file-sharing services like BitTorrent, enabling users to share large files directly without needing a central server. This technology has the potential to disrupt traditional client-server models, offering a more decentralized and democratic approach to digital communication. But what exactly is peer-to-peer architecture? How does it work, and why is it so revolutionary? Well, you're about to find out. So sit back, relax, and let's dive into the fascinating world of peer-to-peer architecture. So, what exactly is peer-to-peer architecture? Well, let's break it down and simplify this seemingly complex concept. Imagine a bustling marketplace where everyone is both a buyer and a seller. Everyone has something to offer, and everyone is looking for something in return. There's no central authority controlling the transactions or dictating the rules. This, in essence, is what peer-to-peer architecture is all about. In more technical terms, peer-to-peer architecture, or P2P as it's often abbreviated, is a type of network design where all participants, known as nodes, share and access resources equally. It's a decentralized system where there's no central server acting as a middleman. The fun part about this architecture is that every node can function as both a server and a client. This means that each node can provide resources like files or bandwidth, and also request resources from other nodes. It's a give-and-take system, where every participant is an active contributor. One way to visualize peer-to-peer architecture is to think of a spider web. In a spider web, each strand is connected to multiple other strands, creating a resilient and interconnected network. Similarly, in a P2P network, each node is connected to multiple other nodes, resulting in a robust and efficient system. The main advantage of this architecture is that it eliminates the need for a central server. This means that the network is not reliant on a single point of failure and can continue functioning even if one or more nodes go offline. It also allows for better scalability, as adding more nodes doesn't necessarily mean more stress on a central server because there isn't one. But it's not all sunshine and rainbows. Peer-to-peer architecture also has its challenges, such as security issues and the potential for unequal distribution of resources. But we'll dive deeper into the pros and cons in the next scenes. In essence, it's all about sharing and accessing resources directly from each other. That's peer-to-peer architecture for you, a marketplace of resources where everyone is a seller, a buyer, and their own bank. Now that we have an understanding of peer-to-peer architecture, let's explore why it's useful. As we dive into the benefits of this system, the first thing that stands out is scalability. In a peer-to-peer network, each new participant, or peer, brings its own resources to the table. This could be processing power, storage capacity, or network bandwidth. Essentially, the more peers there are, the more resources the network has at its disposal. It's like a potluck dinner where everyone brings a dish. The more guests, the more food there is to go around. Next up is failure resistance. Traditional client-server models can be vulnerable to failures. If the server goes down, the whole system can grind to a halt. But in a peer-to-peer network, there's no central server to fail. Each peer is both a mini-server and a client. If one peer goes offline, the network continues to function. It's as if each guest at our potluck dinner brought their own table and chair. Even if one chair breaks, the party goes on. Now let's talk about speed and efficiency. In a traditional model, the server can become a bottleneck, slowing down data transfer for everyone. But in a peer-to-peer network, data can be exchanged directly between peers, making the process faster and more efficient. Imagine if at our potluck dinner, everyone had to queue up at a single serving table. That would take forever, right? But if guests can serve themselves directly from each other's dishes, things move a lot faster. So, why is peer-to-peer architecture popular? It's scalable, meaning it grows with the number of users. It's resistant to failure, ensuring the network stays up even when individual peers go down. And it's fast and efficient, allowing direct data transfers between peers. It's like a potluck dinner where everyone brings something to the table, making the feast bigger, better, and more resilient. So there are compelling reasons why this system is so popular. However, like all systems, peer-to-peer architecture has its drawbacks. Just as there is no such thing as a free lunch, there's no such thing as a perfect technology. For all its advantages, peer-to-peer architecture does have its share of downsides. Let's take a closer look at some of these. Firstly, we have security concerns. Because peer-to-peer networks distribute control among all users, they can be more vulnerable to cyber attacks. There's no central authority to oversee security, and every user is a potential weak link. If one device is compromised, the whole network could be at risk. Secondly, the potential for abuse is another significant issue. In a peer-to-peer network, users share resources directly with one another. However, not all users play by the rules. Some might consume more resources than they contribute, creating an imbalance in the system. This is often referred to as the freeloader problem. Moreover, peer-to-peer systems can be used to share copyrighted material illegally. Without central oversight, preventing this type of abuse can be challenging. Lastly, quality control can be a major hurdle in peer-to-peer networks. Since each peer has the same authority and duties, it can be difficult to ensure that all users are providing high-quality resources. This can lead to inconsistencies and unreliable service, which can diminish the user experience. Despite these challenges, it's important to remember that the peer-to-peer model is not inherently flawed. Many of these issues can be mitigated with the right security measures and usage policies. It's all about finding the right balance between freedom and control. In conclusion, peer-to-peer architecture, like any technology, has its pros and cons. While it offers greater freedom and can be more efficient in certain situations, it does come with its share of risks and challenges. Understanding these is crucial for anyone considering adopting this model. As you can see, it's a double-edged sword. Let's look at how peer-to-peer architecture is used in the real world. First, let's take file sharing as an example. The way we share files today has changed drastically, thanks to peer-to-peer architecture. A prime example of this is BitTorrent. BitTorrent is a protocol that enables fast downloading of large files using minimum internet bandwidth. It does this by breaking down the files into many small chunks, then downloading these pieces from multiple sources simultaneously. This is a perfect example of peer-to-peer architecture, where every downloader becomes an uploader, contributing to the overall speed and efficiency of the file sharing process. Next, let's talk about streaming services. Have you ever wondered how your favorite shows and movies get to your screen so seamlessly? Peer-to-peer architecture plays a crucial role here. Take Popcorn Time, for instance. This service, often described as the Netflix for pirates, uses peer-to-peer technology to deliver high-quality streaming content. Instead of relying on a central server, Popcorn Time fetches parts of the video from a swarm of hosting computers, reducing the load on any single source and ensuring smooth streaming. Lastly, let's dive into the world of cryptocurrencies. You've likely heard of Bitcoin, the digital currency that's taken the world by storm. At the heart of Bitcoin, and indeed all cryptocurrencies, is a technology called blockchain, which is a form of peer-to-peer architecture. In a blockchain, transactions are recorded on a public ledger, which is distributed across a network of computers, or nodes. Each node has a copy of the entire blockchain, and all nodes must approve new transactions. This decentralization is key to the security and transparency of cryptocurrencies. These examples illustrate the significant impact of peer-to-peer architecture on our digital world. So, we've explored the world of peer-to-peer architecture. We've taken a deep dive into this decentralized network model, where each participant, or peer, shares their resources directly with others, without the need for a central server. This model offers significant advantages, including scalability, robustness, and reduced costs. However, it also has its challenges, such as security concerns and the potential for unequal resource distribution. We've looked at real-world examples too, showcasing how peer-to-peer architecture underpins many of the technologies and applications we use every day. From file-sharing platforms like BitTorrent to blockchain technologies powering cryptocurrencies, peer-to-peer architecture is a fundamental aspect of our digital landscape. In our increasingly interconnected world, understanding peer-to-peer architecture gives us insight into the invisible network